Okay, this should be a demo of the Python graphics library for CS 1124, Section 2, Fall 2024. I don't know what else to say for the video header. But what I'm going to do, what I've already done, if you look at the first page, the front page of your graphics reference, you see a little program there. I typed that in advance to save some time, and I named it just for you. Example 4, section 3, edit with idle. Now the way what I'm doing right here, if you go to your H drive, maybe, I'm not sure, but maybe if you right click on it, you don't have to use a magnifying glass. For me, on my computer, it offers the option to edit with idle, and that way it's just a little quicker than using a magnifying glass. But what I did was, to save a little bit of time, I went ahead and typed in their example program so we could just run it and see what they want to illustrate for us about the graphics modules. Does everybody see that that matches the little program here? Okay, so away we go. Run module. Oh! Red paragraph of death already. Well, that didn't last long. Class over. No, if only. No, there's something wrong with this picture. Here's what's wrong. To be able to use a library, specifically for us, the graphics library, they all have to be in the same folder. Fortunately, your long-suffering and attempts understanding instructor emailed you the graphics library and the PDF of this file. When you check your mail later, you should find an email from me that says this, CS1124 Python graphics file attached. And this PDF right here, that's not a PDF. This PDF right here, you'll recognize that. It's what I just gave you a copy of. I would download both of these. If you have the PDF, then you don't have to hold this around with you every time you go to the lab or whatever. You can open up the graphics reference in a window and just look through or search for the things that you need to refer to find out how to do it. I'm old school, so I use the paper copy myself. So you have options. You can go either direction on that. This is the library itself, and I have to download this into the same folder where I have my example program. That's what it was complaining about. So if you get that red paragraph of death, says the graphics module is not defined, it probably, if not certainly, means that you don't have the graphics.py file in the same folder as you've got your graphics program you're working on. While I'm at it, I'll download the PDF as well, put it in the same folder. Any question about that part? And I emailed that to the whole class, so you should have both of those. Now let's try it again. Run module. Well, ta-da. For all that trouble, for all it's worth, here's our little graphics window on our little circle. It's even too small to be cute, but it does show that they were able to open a separate window to put the graphics in, and they put a little circle in there that's tiny and skinny and just not cute at all, so we'll have to work on that. But that's what we have so far. Being that it's part of my very nature, before we go any further, I have got to put some documentation up here. Just bear with me. This is file ex4_03, ex4_03.py. And I'll put all the other stuff later, my name, my address, my social security number, everything that we're supposed to put in the header. But for now, I'm just going to put a description in here. This is going to be demo the Python graphics library. That'll do for now. Now, that'll do for the header block. Mysterious line here. Good news and bad news about that. Bad news, if this line's not there, then this is not going to work at all. This is what connects us to the graphics library. There is a thing in Python called the standard library, the standard boring old same old library that's got eval and input and print and range and all the stuff that we've been using so far. If we're going to get more exotic and do the cube root of some number or something, we've got to include a math library. If we're going to get exotic and do pictures on the screen of circles and squares, then we've got to include a graphics library. Specifically, we have to import it. This says from the graphics library, import, and the star is the wild card. Just import everything. This graphics library that's documented here is not very large. So we're not eating up huge amounts of storage or anything to just say, you know what, give me whatever you got. Your circles, your squares, your rectangles, your triangles. Import them all, bring them all in, because I don't know which ones I'm going to use. I'm going to make it up on the fly. If you wanted to get more selective, you could say something like from graphics import circle. And then you could draw circles and you couldn't do anything else. But this line, that was the bad news, that you have to remember to put that there. The good news is it's always exactly that line. It's like the def main parentheses colon is on every program. All of your graphics programs will have this. And the purpose for this is to connect to the graphics library. Now then, and this of course, I can't see the cursor. This is the main program. No, not there. Come on already. Main program. There. I'm a little more comfortable with that. I still am experiencing some discomfort though. And I am going to, I'm not going to risk anything. Every time I make even the dinkiest little change, even add comments, I'm going to run it again. And there it is, a tiny little box with a tiny little circle, so I didn't break it. Now, this is strange. It says it's still running. Why is it still running? Well, when we run graphics programs, we will have to click the mouse inside the graphics window to say we're done with it. Click, and there it goes away. And now we're done. So now we've exited the program, and here's the program. And I don't know. If you know me well, then you know that there's all kind of discomfort I'm experiencing with this. For starters, let's see. Let's just do one line at a time. When equals, that looks like we're assigning a value to a variable. In fact, we are. A convention when you're working with object-oriented programming and objects, object types, by convention, they're camel case, but they start with a capital letter. So if we glance through this code here, we see that graph when starts with a capital G. That's a type of object. That's not a variable. It's not a symbolic constant. Circles, a type of object. Point is a type of object. Anything that's a type of object that you're using graphics has a description inside this document. Let me put my money where my mouth is. Graph when is on the front page. You don't even have to flip pages or anything. Graph when. A graph when object represents a window on the screen where graphical images may be drawn. Well, how handy for us, because that's what we want to do, draw graphical images. A program may define, don't worry about that. We're only going to have one graph when for every graphics program we do. But here's important stuff. A graph when understands the following methods. And you'll remember methods correspond to the operations on an abstract data type. Somebody went to all the trouble to write up what would be nice to be able to do with the graphics window. And they wrote those up as methods for the library. One of them has got to be, you got to be able to make one of these things. You've got to be able to make a graph window, and that's what the very first method is. The very first method on all of these will always be the name of the object type itself. That's how you make one. You make a graph window by specifying a title and a width and a height. It says, constructs a new graphics window for drawing on a screen, and then it gives you an example. And their example, I don't like the example either. When equals graph when, investment growth, and 644.80. Okay, I've stood it as long as I can. What do you suppose is making Dr. E? Not everybody would be, but I am. What's making me uncomfortable about that line? Someone that got a lot of extra red ink on their project too. Let's understand this line. We're making a graphics window, and my circle, that's probably the title. Yeah, that matches the title. What's the first 100? What's the second 100?
They're numbers, not strings.
They are numbers, they are not strings. They've got to be numbers. But if we look at our handy-dandy graphics reference, it says that those are what? What are the second and third things in parentheses? The width and the height. To me, it just looks like two arbitrary, almost random numbers, 100, 100. Those don't mean anything. So, how can we fix that? We can fix that, you guessed it, with symbolic constants. Width, I'll yell it. Hope I didn't break my microphone. Width equals 100. Height equals 100. Now, look what I can do. Look what I can do. This is so much more self-explanatory now. My circle is clearly the title, and the width is width, and the height is height. I breathe a little easier now. Let me make sure that my easy breathing did not break it. Still works. Okay? Now that I'm getting so into my own comfort level here, I don't like how tiny that window is. How do you suppose I could make a bigger graphics window to draw bigger stuff in it and more things in it?
Changing the color.
Change the width and the height. Exactly right. Tweak the symbolic constants. Now, where we are, going down the road here, with symbolic constants, you can view this up here as like a little fine-tuning zone. This is like if you've got a radio and you've got a knob that can change the station you're listening to, and another knob that changes the volume and all that stuff. We can tweak the program using nothing but the symbolic constants if we've used our symbolic constants wisely. So I'm going to say the width, I'm going to go for broke and make it 500. Why not? And the height, I don't think the width and height to be the same. I don't know. Let's run an experiment. How about 400? Now, automatically the width and height for my graphics window will be adjusted to 500 and 400. Let's see if it still works. Yes, yes. Now we're talking. Oops, I clicked on the wrong window. It's still there back behind the scenes. I got to click on this to make it go away. Otherwise I get a warning or even an error. So it did work. I've got a width of, I didn't want to do that either. I've got a width of 500 and a height of 400, but when I run it, I was talking and clicking so fast we didn't get a chance to see it very well. If I run it, the little circle, bless its heart, it's not in the middle anymore. I want that circle to be in the middle. It's so hard to see anyway because it's so small. Let me clean this up and then we can talk about recentering the circle. Let's look at the circle object. I know it's an object type because it starts with capital C. Circles. Circles are on the back of the second page, also known as page 4. Circle methods. Constructs a circle with the given center point and radius. Here's what makes me uncomfortable about this. I do not like objects that are created on the fly. And by that I mean, if this circle needs a point to represent its center, then make the point first, for crying out loud. I'll even call it center point, C-E-N-T-E-R, point, equals. Now I've got to look up point object. That's in the middle of page 3. Point objects are easy, just one set X and Y. I'll stick with what they have. Center point equals a point object. I'll use that method to make a new one. And look, it's trying to help me make an X and Y. Okay, 50-50. There. This will relieve a little more of my discomfort. Now I don't make the point object on the fly. I make that as a separate assignment before I even make the circle, and now I can say center point. And I act as if it's all just intuitively obvious, and yet I might have broken it again. Run module. And, well, it still works, but the circle is not in the center. Where is the center if the width is 500 and the height is 400? 250, what you said 250 and 2?
150 and 200.
Well, now wait a second here. If it's 500 across, 250, that's what you meant to say. 250 and 200. That's what you meant to say, right? Yeah, I thought so. Run. Let's see if we fixed it. Ta-da! Not only do we have a bigger, easier to see graphics window, we have a circle that is right smack in the middle. We are on a roll, and I'm feeling so good about it, I'm even going to make a bigger window here. 650, my goodness. Shoot the works. 500. This will be great. Oh, this will be great. I can't wait. Oh, no. We kind of sort of broke it a little bit. The circle is not in the middle anymore. How could we make it so that the circle is self-adjusting. In other words, I want that circle to be right smack in the middle regardless of what I do with the window.
Have a variable that's center width, center height, and divide them by 2, and assign those values to the.
You can set up separate variables, or we can do what's parameterizing the point construction. Parameterizing something means that it either depends on a variable or a symbolic constant. What do I want the x and y coordinates to be of the center point of the circle if I always want that circle right smack in the middle of the window?
Always make it half divided.
Half of each. Width divided by 2. Height divided by 2. Don't let me get away with anything. Even though this is going in the video, this is the time, the prime time to ask questions. Does everybody see what the plan is here? Go halfway across and halfway up or halfway down or whatever. We haven't discussed that yet. But we need half the width and half the height for the x and y coordinates. I think we do. The only way to see is to try it out, and sure enough, it's right smack in the middle. I'm just not confident though. The width, I'm going to go for even broker and make that 800. And the height, I'm going to squish that down, 350. If this behaves the way we want it to, then this point is going to float around the center point of the circle so that it's always right smack in the middle. And in fact, it is. Right smack in the middle. And if you haven't been convinced up to this point, then I hope that, there you go. I hope that beyond this point, so to speak, you do see increasing utility for our symbolic constants here. I can tweak these to whatever I want, and everything that depends on the height and width of my window will adjust itself if I use those symbolic constants throughout the program. I don't have to change the coordinates of the center point of the circle because they are parameterized on my symbolic constants. Now then, that circle is too little. What if I want the circle to be altogether half as tall as the window? What could I do? What could we do? Let's look at circle and see what it wants from us to be made. I should at least memorize where these things are, and yet I have not. Circle is at the top of page 4. Circle wants a point. We've got that all over the place here. We've got center point on steroids because we've made a point separately. The radius. The radius, what could I do for a radius that will make it so that the height of the circle is always half of the height of the whole window? Is that just too easy of a question? Don't make it hard-coded 10. Let's parameterize off our symbolic constants. If I want it to be half the height of the window, what could be simpler? Right? Am I right? Can I get an amen? Whoops. That's a little bit tall. If that's supposed to be half the height of the window, I think we overshot it a little bit. What's wrong with this picture? Where's the radius of this circle? It's not drawn on the screen, but if I were to use the mouse to trace the radius, where would I start? In the middle, out to the edge. So even though it's not what I intended, it did exactly what I told it to do. I said, make a circle where the radius is half of the height. If the radius is half the height, that's the distance from the middle out to the edge. And there's height divided by 2, and here's another height divided by 2. Back to the drawing board. Oh no, I should have thought of all this in advance. Not necessarily. You just throw stuff at the wall and see what sticks. That didn't work. So we go back to the drawing board, also known as the editor window. What should this have been if I want the total height of the circle to be half of the height?
Width divided by 4.
Width divided by 4. Let's try that.
Not width, height divided by 4. Height divided by 4.
The other width. The height divided by 4.
Yeah, one word, right, sorry.
That looks better. I mean, I'm not going to get a ruler and measure it, but it looks like the height of that circle is half the height of the window. Does everybody agree? Does it really matter if it's height or width? Does it? What's this going to do? Can you predict before we even run it? You better hurry, I'm clicking to run. Oh! It didn't even give me an error message, but the circle went off the edges. What's wrong with this picture? The radius is too big. The radius is now half of the width. No, the radius is a quarter of the width. The width of the circle is half of the width of the whole thing. And we could just say, well, I meant to do that, but we didn't. So I'm going to go back and change this back to height. And make sure I unbroke it correctly. Okay. Now, let's see. What else we got going on here? Who has a question starting with the window? And WIN is just a variable, by the way. I'll prove it. I'll make it just plain old W. And everywhere they've got WIN in their example program, I'll change it to W. You can use anything you want for your variable names. And since they use single letter for circle, then I could use W for WIN if I want to. I hope I didn't break it. Still works. Okay, so you can, what we're doing is taking a GraphWin object that we create with the library and storing that entire object in variable W. It's a mind-blowing concept. It's not just a single number or a little string or anything. It's an entire graphics window. So anything we do to W, we're doing to the entire graphics window. This point here, this point is being stored in a variable named center point. The circle's being stored, the circle object, excuse me, is being stored in a variable named circle. And then we come to some really mysterious stuff. But who has a question about the first 3 lines of this program, first of all? Feel good, feel strong, all that make perfectly good sense? I guess we'll find out tomorrow morning, won't we? What about C dot draw circle? Let's look and see what the circle method draw does. The top page 4, there's all the stuff you could do with a circle. What does it say about draw? Not a whole heck of a lot. Here's the deal. This, even though it's not a very deep family tree, this is an object-oriented programming library, which means all of these different shapes, the circle, the rectangle, the oval, the polygon, all of the 3-point something, 3.3, 3.4, all that, all of those are child objects. They inherit from the bigger, more general type of object, graphics object, that starts on the bottom of page 2. Do you remember in the very sort of waving hands overview of object-oriented programming, we had animals. More specific type of animal was a dog. I don't even remember. A dog, an octopus, a fish, and all that stuff. Okay. We have, playing the role of animals in this library, graphics objects. That's the general. Everything is a graphics object that you can draw on the screen. The more specific types are circles that have radiuses and rectangles that have, I don't know what they have, ovals that have other stuff, polygons that have other stuff. Those are more specific types of graphics objects. Now, the implication of that is all of those methods that are listed under graphics objects, all the other things can do those as well because they inherit those methods. I'm hoping that that terminology is sounding familiar. When they inherit the methods of a graphics object, that means they can do anything a graphics object can do and then more. So the only stuff that they list under circle and rectangle and so on is the more that they can do because they're a more specific type of graphics object. This is what a dog can do that not all animals can do. If we look at what all animals can do and look for draw, it better be there. It is. It's at the top of page 3. Draw inside a graphics window. Draws the object into the given GraphWin and returns a drawn object we don't need to return. But look at their example. Some object, they're being very generic about it, some object.draw inside some window. So that's what this is doing. This is saying circle, draw yourself inside window W. Now, if it's not clear what that does, here's another experiment you can run in the lab, or I can run it in the demo right now. bonk, it's gone. I commented it out. Just so I can run my experiment and say, I did all this trouble. I made the center point. I made the circle. What if I don't draw it? Let's see. Run module. Well, I think we have our answer. It does have a circle. It's sitting there in memory, all ready to go. It's got all those points that need to be drawn around the edge. The circle object knows how to set up all that stuff. It just doesn't show up. And if I click on it trying to make it show up, it's done. It disappears. That's how you find out what these things are doing if you're borrowing code from the library or elsewhere. See what happens if you take them away. What about wgetMouse? That had a comment that came with it. The W is a GraphWin object. So I looked in my handy dandy library. Now GraphWin does not inherit from graphics object. It's a separate kind of object all by itself. And the getMouse method. Where are you? getMouse is near the top of page 3. Pauses for the user to click a mouse in the window. Okay, let's see about that. Does anybody want to predict what's going to happen when I take that line away? So I get rid of the getMouse and run it. Anybody have a prediction? Is it going to draw the circle?
Yes.
Yeah, I uncommented that, so it should draw the circle. But it doesn't pause for the mouse. Let's see what happens. Whoops. Did you see it? Let me run it again. Do you see the window with a circle in it? I saw a window flash before my eyes, but I didn't see a circle. Apparently, if we reverse engineer because we didn't understand the description, what is getMouse doing?
Waiting for the mouse's input.
It waits until you click the mouse before it goes on to the next line. If we don't do that, it runs through the program as fast as it can and it's done. All done. Window goes away. Takes the circle with it. The getMouse is what you got to put there if you want to stop and see what you've done before it just runs through the rest of the program and quits. Okay? Now, question up to this point. Let's talk geometry, coordinate geometry specifically. If you had a geometry class where you had to draw pictures on graph paper and stuff, you're probably used to an XY coordinate system where the X goes up, the Y goes across. No. X goes across. You knew I was wrong. I was doing that, see if you were paying attention. X goes across and Y goes up. Not in this graphics world. The point up here in this corner, the upper left corner, that is 0, 0. So as the width gets larger and larger, and we move over here to 500 or whatever it is, it's growing as we go from left to right. The one you got to keep an eye on, the weird one, is the height. Because the height is upside down. It's more like a reflection in a pond or something. It starts up here at 0, and the height increases as I move down the screen. Does that make sense? Prove it. This is defying the laws of physics. This ball is not going to float in the middle of the sky. This ball is going to behave gravity, and it's going to be on the bottom edge. How can I change this circle or anything about this so that the ball, we'll call it a ball, is down here on the floor? And we'll put it right smack in the middle of the floor. What's going to have to change about the circle? I guess I could change the radius, but no. We'll say that's cheating. We're not going to make a bigger ball. We're just going to move the ball so that it's sitting on the floor. What needs to change? The X coordinate, the Y coordinate, both of them?
Center point.
You have to
The center point of the circle is going to have to be different. Now put on your geometrical thinking caps. How far across do we need to go for the center of the circle if the ball's going to be on the floor? Still the same, width divided by 2. What about the height? Do we go halfway down?
have to go all the way.
All the way down. Let's try that. So the center point, that's the only thing that's going to have to change. And now, if you believe me that the height is upside down, then we'll just say go all the way down. Oops, I don't want to configure idle. I want to run the program. Yes, ma'am?
With the center point, yeah, that's what I thought.
Well, It probably would have been helpful to know that the ball was made of lead and went through the floor. That was not the intent. How can we make it so that the ball sits there lightly on top of the floor? Apparently, we don't want to go all the way down. Now think about this. This is very literal. Python, like all other programming languages, they do not do what you intend. They do exactly what you say. And that can be the boon of our existence if we're not in control of it. It did go halfway over, check, but it went all the way down for the center point of the circle. And all the way down is the floor itself. How far above the floor do we want the center of the circle to be? The radius back. So what do we have for radius here? The center point is halfway over, and the radius, oh my goodness, we're going to have to do some math. I'll just get this out of here. This is no longer good. We've got to come up with a new y coordinate. We could say, you know, here's one way we could do it. There's more than one way. I could say go all the way down to the floor, which you do by spelling height correctly. I need a stenographer or a scribe or somebody. I'll just talk. Somebody could be the typing robot, and I'll just talk and you just type stuff in. Okay, the height, we've seen what that does. It goes all the way down to the floor, and then we need to back up a little bit. So it's almost like the ball is bouncing to where it belongs. How much do we want it to bounce up if we want the ball sitting on the floor? A quarter. Height minus height divided by 0.25? What's a quarter of the height?
Height spelled wrong.
Highest, without an S. Is that right? H. That's what I get for choosing such complicated symbolic constant names. What it looks like, this is going to, I mean, it's almost like physics in action. It goes all the way down to the floor and then comes a quarter of the way back up. Is that what we want?
Yep.
I guess we could find out, can't we? Oh my goodness. It looks like we are geometrically proficient, or so we'll claim. So that worked okay. And I said that there was more than one way to do this. You could also say 3/4, 3/4 times the height. So there's another way. But this way, I get to use my bouncing ball metaphor, which goes all the way back to day one. We're beyond bouncing balls now. What else could we do here? Oh, you know what? Let's fancy this up a little bit. What color should a ball be? A bouncing ball that's not made out of lead. Red. I couldn't have chosen a better color. Let's look at circles and see how to color them red. Circles at the top of page 4. Which one of those is going to color the circle red? None of them. So we can't do it? If we can't find what we want in the circle methods, then where's the next place to look? The graphics objects. And hope that we can inherit a way to change the color. Do you see a way to change the color? That's a yes or no question. Do you see a way under the graphics objects methods that we should be able to change this to color of a circle or a square or anything else we want to change color of? Yes, what is it? Set fill. So it's got to be after we've made the circle. We still got to be careful about getting things in the right order. We could say C dot, and it's set fill camel cased. And I bet red is a color it knows. That's a pretty basic color. Red! Run. Run like the wind. Run, Forrest, run. Oh my goodness, that is a red ball if ever I've seen one. Let's say that it's a radioactive red ball, and I want the outline to be green. Work with me here. So how can we find a way to set since we're on a roll, how can we set the outline to green? Probably set outline would be my good guess. You tell me what to type. Excellent. You're graphics masters already. Man, I can't tell. How can we make it thicker?
Set width.
C dot set width. And C dot set width wants a number of pixels. Those are dots on the screen. I mean, that's absolutely, for me at least, that's absolutely trial and error. But I'm going to use this another symbolic constant because I don't want to be plugging numbers in here. I want to be able to turn these knobs up here and get the color and the width and the height and all that stuff to change. So this will be ball. Oh, it's a ball. Why not? Ball width. Ball line width. I don't know. That's a long symbolic constant name, subject to typos. I'm going to start with 10 and see if that works, and if it doesn't, then we'll try something else. Ball line width. It might already be 10, I don't know. Oh, that looks better. That shows, it actually looks pretty Christmassy. I felt the flash of Christmas spirit when that showed up on the screen. Who has a question about this so far? I think it knows the light version of most of the colors. I think I've used those before. Let's see, light green's going to make it look less Christmassy and more radioactive. Yes, definitely. A glowing red ball. I wouldn't play with that ball. And I absolutely wouldn't toss it to my dog. Let's press our luck and dream big. Let's put the word ball with an exclamation point up here above the ball, right smack above the ball, the center of the ball. And we want to label it. So it's got to be words, it's got to be string, it's got to be a text. Where do you see an object that might allow us to put words on the screen?
Get text.
What kind of object do we need?
Text box.
We need a text box, which is, if you look at text methods, 3.7 on page, is that page 5? Yes, page 5. We've got to make a text object, just like we made a circle object. And we need to do that before we get the mouse and everything disappears. So I'm going to say, what am I going to say? T equals text. Text. Think about it while I'm trying to type it. What does it want to make a text object? An anchor point. I don't even know what to call that. I'll call that text point. I'm sure it is an anchor point. It's the center of the text box, the way the circle center is the circle of the circle box. That was a tongue twister, and I got it right the first time. I'm using objects that I haven't made yet. So I need a point and I need a string. We'll just dump the string in there. Ball! Exclamation point. Now, I'm going to run this, even though I know it's not going to work. Now, I can't see it because this is the graphics window and it doesn't even disappear. It didn't get to the line that says wait for the mouse because, move, you're in my way, editor. I did get the red paragraph of death. Text point is not defined. So I'm not managing the screen very well, but on the bigger screens in the lab, it'll be easier to have this window on the screen. This is our good old-fashioned console text window where we see the output of print statements and everything. Also any error messages that show up. So now we've got 3 windows going on the screen rather than 2. We've got the editor where we go in and make changes, and I need a text point. And I've got the graphics window and all this stuff, and it's hard to juggle on my tiny little laptop screen. Text point, and with your able assistance, you can tell me what kind of object does this need to be? Who's buried in Grant's tomb? What kind of object does the text point need to be? What did the center point of the circle need to be? What kind of object? It's a point object. Starts with a capital P. Point object. How far across do we need to go if we want this to be centered above the ball? Width divided by 2. Symbolic constants at work for you. This will be self-adjusting. I'll prove it one more time if I remember to, by changing the width and height after we get done with everything. How far down, if I want it to be, you know, balanced so that it's above the ball but not touching the ball and all that stuff, how far down? Let's parameterize that as well. Let's say how far down in terms of the height so that it'll self-adjust when we go to a different window size. I didn't hear what you were saying. Is that what you were saying? Let's try this real fast, see if it'll work. Oh no! We broke it. Well, we didn't break it, it just didn't do everything. Why didn't it show my text on the screen? It's actually, what did I do? Look at this carefully. What did I do with the circle to see it that I did not do with my text object? You gotta tell it to draw itself. I call that the mother may I step. We went to all the trouble to make this text object. Now we've got to tell it to draw itself in the window. It seems like a silly extra step, but let's see if this silly extra step solves the problem. Run module, okay. Well, it's tiny, but it's there. Ta-da! Ball. Yeah, we'll declare success and move on. Who has a question about what you've seen so far? I am going to document this before I release this version of the source code. I will email you this one and both of the demos. I did a different demo in the first section. It's the same features but a different picture. And what else? I will send you links to the YouTube videos when they're uploaded. And now I think we are done. Cut.